In this video, we will see the working of a SR latch with a control input, and this understanding of the SR latch with control input will be used to understand the flip flop and the further whatever flip flops we are going to learn about. Now, before we explain the SR latch with the NAND gate as a control input, first let us understand the property of a NAND which is going to be used here. So property of a NAND means, so let us take there are two inputs x and y, and the output is, let's say, z, and we are writing the truth table for the NAND gate. So in NAND gate, if the input both input are 0 0, then the output is 1. If input is 0 1, then the output is 1. If input is 1 0, then also the output is 1. And for the input 0 0, then the output is last one input is 1 1, then your output will be 0. So this is what a NAND gate represents, and what we should look at this NAND gate is, see, the if the one of the input is 0, that means whatever the second input is, either it is 0 or it is 1, so that doesn't matter, the output is going to be remain at the value equals to 1. So that means if one of the input to the NAND gate is equals to 0, then no need to look at the other input, the output is going to be 1. So this is a basic understanding. So with this basic understanding, we'll try to analyze the circuit now. So let us take case 1. Okay, so in case 1, what happens? In case 1, let's think there is a enable pin which is our control input. If the enable pin is equals to 0, so we are not talking about this value of S or R. Let us understand, if the enable pin is equals to 0, then what will happen? Okay, so if enable pin is equals to 0, then here the condition is one of the input to the NAND gate. The enable pin is given to the this NAND gate also and the downside NAND gate also. I am fixing one of the input is equals to 0, so the output is always going to be remain as 1. So here it will, the output will be 1, and here the output is going to be 1. So now you see, let us assume that the previous condition is 0 here and this value is equals to 1, because it is q and q dash, so always they will be in complemented form. So let us assume that previous case is like this. So the condition we are taking here, enable pin is equals to 0, and the previous condition q is equals to 0 and your q dash is also equals to 1. So with this condition, what will happen in the next state? So that is what we are going to see. In the next state, what will happen? Now this is what given is the current state. Currently it is available, enable pin is 0. So here the one of the input is equals to 1, and in this case also the input is equals to 1. So if both the inputs are 1, so you can see this NAND gate property, the output depends on the other input. If other input is 0, output is 1. If other input is 1, then the output is equals to 0. So let's apply it here. So we have taken an initial condition, that is q is equals to 0, and it is given feedback to this NAND gate, so it becomes 0, and also q dash is equals to 1, so this is as a feedback coming to here, the value is equals to 1. Now we see, if the input is 1 1, if the input is 1 1, this is the condition. 1 1 means the output is equals to 0. So here the output will be equals to 0, and input is 1 0, then the 1 0, then the output is going to be 1 here. So what we observed, the value of q is equals to 0 and the value of q dash is equals to 1. Now you can see this value is same as the previous value. Okay, same as the previous value. That means initially the value was 0 1, now also the value is 0 1, it has not changed. Okay, now let us see, if I change the initial condition. So change the initial condition with enable pin equals to 0. Let's say q equals to 1 and q dash is equals to 0. So now instead of 0 1, we have the inputs as 1 and here it is 0. Now what will happen, the scenario is going to remain same. Let me wipe out the previous cases. Okay, so here one of the input is 1, here one of the input is 1, because enable pin is 0, I have not changed that. So that input is going to remain at 1, and the feedback from q is given to the r dash NAND gate. So here the input is 1 and the q dash is given here, so it becomes 0. Now 1 0 means 1 0 means here the output is equals to 1 and 1 1 means the output is 0. So what happened in the next state? So in the next state, the value of q is equals to 1 and the value of q dash is equals to 0. So which is same as previous state? So which is same as the previous state. So now what to observe here? If enable pin is equals to 0, then the current state and the next state is remaining same, there is no change. So in the first line of the table it is written, if enable pin is 0, then whatever the input of S and R, that doesn't matter, there will be no change in the output. Fine. So how it is happening? If enable pin is equals to 0, now these two NAND gates, this 1 and 2, these two NAND gates will give output as equals to 1 independent of the value of S and R, and accordingly depending on the q and q dash, the output will be decided for the next state, which remains same, and here it is written as no change. That means my latch is behaving as a memory, it will not change its value. Okay, now let us go to the other condition where I give the enable pin value is equals to 1. So we'll just keep the NAND gate table as it is, we'll wipe out the other case. So the other case, let us write case 2 where enable pin is equals to 1. So here I am writing on the top because I am not going to change for rest of the case. For enable pin equals to 0 we have already verified. Okay, now what changes here? The value of enable pin will be equals to 1 and let's see what happens with that. This is equals to 1. Okay, now if one of the input to the NAND gate is equals to 1, then what will be the output? So if one of the input is fixed at 1, the output depends on the other input. Fine. So for that, let us take a condition. If the input S equals to 0 and R equals to 0, both the inputs if it is 0, so here S equals to 0 and R equals to 0, this is the condition we are talking about. And let's say in this condition Q equals to some condition will take 0 and Q dash is equals to 1, so like this we take. Now let's see what happens. So if S equals to 0, the NAND gate 1, 1 2 3 4, let me write. So one NAND gate 1, if one of the input becomes 0 here, so obviously the output is becoming 1. We no need to check for the other. In this case also, one of the input is equals to 0, so the output is equals to 1. And in the previous case, we just discussed, if here the value 1 appears, then the rest of the circuit is going to behave as a memory. That's because here one of the input is 1 and here one of the input is 1. Now if q equals to 0, so q equals to 0 will be appearing here, so 1 0, this will give me the output is equals to 1. The previous value of q dash as 1, here 1 will be given, so 1 1 will give me 0. So if you see, the previous state and the next state is remaining same. So in this case, in the next state, so in the next state what will happen? So q will be equals to 0 and q dash will be equals to 0, that behaves as no change. So there will be no change. If I take q equals to 1 and q dash equal to 0, then same thing is going to happen. So here also the second case we have verified where no change, and this condition we call this as memory state. So that is also called as memory state. Now let us go to the third case. So case 3. So in the third case, enable pin is obviously at the condition 1, that's why the flip-flop latch will work, and we will take the input S equals to 0 and R equals to 1. So this is the, previously we have taken 0 0, now we are taking 0 1. This is what we are taking now. And let us assume whatever the previous value I can take, I will take q dash equals to 1. You can take the opposite also. Now what will happen? So let's see in the latch what will be the output. Okay, so this is NAND gate 1 2 3 and 4 here, and we are taking this is equals to 0, q dash equals to 1. So what the input S and R I am taking? So S equals to 0 and R equals to 1. Let's see what happens? So if one of this input is 1 and other input is 0. Now if the input is 1 0 for the NAND gate, then the output is equals to 1. Okay. Now here one of the input is equals to 1. Another input from enable is also equals to 1. See, both are 1, then the output is going to be 0. Okay, now let's see. Here the value is equals to 1 and here the value is equals to 0. So what we have observed in NAND gate, that if one of the input is equals to 0, no need to check the other input, the output is going to be 1 here. So the output will be 1 here. Now whatever the value of q, this the 0 or 1, that doesn't matter, whatever value is here 0 or 1, because another input is fixed at 0, so the output is going to be fixed at 1. So in this case, in the next state, once the input is given, so what will happen? The value of q dash is becoming equals to 1. What will be value of q? Let's see. So if q dash is going to be 1, so previously it may be 1 or 0, but because of the current input of s and r, the q dash is going to change to 1 or it is going to stay at 1. Now this is the input given, will be appearing here. Already I am giving, it is receiving the NAND gate number 4 is receiving as signal as 1. So 1 1, so 1 1 will make the output as 0. So where the output is 0. So that means q is equals to 0. Now if you see, this will continue till the input is there. So now the 0 feedback is given here. So 0 0 will give you 1. Okay. And then here 1 is there, 1 feedback is going here. So 1 1 will give you 0. So the value is not going to change. So this is also we call, sorry, this is 1. So this is also we call as set state. Okay. So set state q0. Now this is 0, sorry for the mistake. Q equals to 1, this is called as reset state. Sorry, reset state. So this is what we are talking about, it is called as reset state. If s equals to 0 and r equals to 1, it is called as reset state. That means whatever the previous value of the flip flop or the latch was there, it will overwrite and the new value will always be the new value, this will be 0, sorry, the new value will always be 0 as q and 1 for q dash. So this is going to be fixed, so that's why it is called as reset. And the output or the flip flop behavior, we generally see what is the value of q and accordingly we say it is reset or set. In this case we got that if s equals to 0, r equals to 1, it is reset state. Now let us go to the next condition. So let's see case 4 now. So we are talking about this condition. Let's wipe everything. Okay. And now we are talking about this particular condition, case 4. Enable pin is equals to 1. So that is, so we are keeping as constant. Enable is equals to 1. And in this case, the value of s, let us take 1, and the value of r is equals to 0. And the previous value can be anything, 0 or 1, or here q dash also equals to 0 or 1. So the previous value can be anything, doesn't matter. Now we'll see what happens in the next state. Okay, enable pin is equals to 0, s is taken as 1 and r is taken as 0. So here 0 will be appearing and here 1 will be appearing. Now here the input is 1 and the enable pin is giving 1, so the output is going to be 0. And in this case, if one of the input is equals to 0, no need to look at the other one also, the output is obviously going to be 1 here. That means to this NAND gate 1 is given and to this NAND gate 0 is given. Okay. Now let us see, if 0 is given here, we already know that if 0 is one of the input, we no need to look at this, whatever it may be, it doesn't matter, don't care condition, the output is going to be 1. So if this output is fixed at 1, so this feedback is given to the this downside NAND gate. So if 1 1 becomes input, the output is going to be 0 and it is going to stay as the same condition. Here q equals to 1 and q dash is equals to 0, and this is called as set state. Set state, why? if the q equals to 0 and q dash equals to, sorry, q equals to 1. So if q equals to 1 and q equals to 0, so this is called as set condition or set state. So this is what written here. So if you see in the table, we are not mentioning even q dash or q bar. So we are only mentioning q because the q and q bar are always complement to each other. It is called as set state. So what is set state? When the set input or S input is equals to 1, when the reset input or R input equals to 0, then the latch will be in the set state. That means the in output will be observing the value that is equals to 1 for Q1, sorry, for Q. So from these previous two cases, you should notice here, if S equals to 0, then next state Q equals to 0. If S equals to 1, then the next state Q equals to 1. So we can say that if the set value is equals to 0 and the output is reset, if the set value is equals to 1, then the output is set. So with this, let us go to the last stage, that is last stage, that is case 5. So in case 5, what will happen? Similarly, we are taking enable pin equals to 1, no change is there. And in the flip flop, let's say we remove everything. Okay. Now we are taking the input where S equals to 1 and R equals to 1. Okay, so both the values are equals to 1. Let us see what happens. So here S is 1 and R is 1. We are taking giving the input as 1. So 1 1, the output is 0 here, and here 1 1, the output is 0 obviously. Now see, the 0 output is here, 0 is here. Now if to this AND gate one of the input is 0, so the output is going to be 1. Here also the one of the input is equals to 0, so the output is going to be 1. So in next state, what happened? Next state, we saw that q is equals to 1 and q dash is also equals to 1. So what happens? Which is a invalid condition or indeterminate. So we call this invalid condition or indeterminate condition. If both the inputs S and R becomes 1, then the output is cannot be determined. So that's because it's not a valid output. Whatever the previous value doesn't matter. The output, both output will be 1. And this case is never used in SR latch or flip flop that we are going to read later. And in the next video, we'll see about D latch. So what is D latch and why it is called D latch, that we will see in the next video. So thank you for your attention.